Hello everyone, my name is Mohammed A. Razzak. I am an undergrad at the Lewis University. We read a paper from physics letter B. It's called Observation of a New Particle in Search of the Standard Model Higgs Boson with the Atlas detector at LHC. Basically, we read a paper on Higgs boson. So what is Higgs boson? Where did it come from? Higgs boson is a particle, and it was created millions of years after Big Bang. And basically, during this time, there are protons, neutrons, electrons. They're roaming freely and massless. They had no mass. They needed a scalar product to get their mass from. This is where we get the Higgs field from. Higgs field, aka Higgs boson, gives all the fundamental particle its mass except the photon. Photon does not get its mass from Higgs boson. Photon is particle of energy. So all the fundamental particle, proton, neutron, electrons, quarks, all of these stuff get their mass from Higgs boson. The physicists theorized this in 1964, and the ones who theorized it was Peter Higgs and Francois Igler, and they theorized it because in the standard model of particle physics, they did many tests on mechanism and breaking down electroweak symmetry. And from the experiments, they figured out that there has to be a scalar factor that gives everything its mass. This is where the Large Hadron Collider comes in. Basically, the Large Hadron Collider, they collide particles, proton particles, proton antiproton collisions, and when this collision happens, at that instant of time, there's this small energy that is created in that field due to this collision. And from this collision, there are hundreds and thousands of particles that are created. There's electrons, there's quarks, there's all different types of quarks. And usually, once in a while, you find this one Higgs boson. And this Higgs boson, it doesn't stay around for a while. What it does, it decays into different fundamental particles. It decays into quarks, or it decays into something else. So to experiment on Higgs boson was difficult. It was difficult, but they did it. There was the Atlas detector, and they had to do many different background checks. They had to they did different experiments on each detector to have anything that was an outlier to like take out any of the outliers. They did background estimation. They did almost everything. Because they had some initial data, they figured out an initial and a final value for the Higgs boson. They said that it would be in between 116 GeV and 127 gigaelectron. And at the end, they do find this particle, the Higgs boson, and they find the mass to be 126 GeV over c squared. But the question that arises from this is the top quark. As we know, there's up, down, strain, charm, top, bottom. The top quark has a mass more than Higgs boson. The Higgs boson has a 126 GeV c squared over c squared, and the top quark has 173.07 GeV over c squared. The question here is, if you get your mass from something, how are you gonna have mass more than the actual particle itself? It's like saying, I eat a pound and I gain 2 pounds. That's the quite Leibniz analogy here, but quite literally, this is the new field of research. It was the Higgs boson was found in 2012, So it's recent, and they're still testing different experiments, and they're still trying to find about this particle, and finding Higgs boson and knowing about the Higgs boson, it completes the standard model. It gives us and everything. It gives us the starting point of the universe. Not the Big Bang, but the starting point, the start of creation. It gives us the start of almost everything. Higgs boson. That's it from me.